Good morning, students. For today, let's do question number 2 of exercise 4.3. Question number 2, we saw that the points point A, B, and C are collinears. The period of point A ga B ga C ga moi hum se collinear oina utlo ba. Koina mamangi class ta kai tamre. Area of the triangle puthokpe and condition of collinearity of 3 points puthokre ko. If the area of the triangle formed by the given 3 points is equal to 0, then the 3 points are said to be collinear. Nangi area of the triangle se nang na 0 chataragadi 3 points se collinear uena khanduini ko. Let A, B, and C given condition hatani ko. A, B, C are the given points. Then find the area of the triangle formed by point A, B, and C, which is given by 1 by 2. A, B plus C 1, B equal C plus A 1, and C A plus B is equal to 0. Then expanding this determinant along first row, we get area of the triangle ABC is equal to half. Expanding along first row, first element is A. Then find the determinant obtained by deleting first row and first column. Determinant says C plus A 1 and A plus B 1 tareko. Expanding this determinant, we get C plus A multiplied by 1 minus 1 into A plus B. It will be equal to minus A and the minus B. Your second element is B plus C. Find the determinant obtained by deleting first row and second column. And so the determinant is B1 and C1. By expanding, we get B minus C. Your third element is equal to 1. C tareko. Then find the determinant obtained by deleting kana-kana ani first row and third column. B, C plus 1, C and A plus B is the determinant. Expand out to C, we get B into A plus B, which is equal to AB plus B square, and C plus A multiplied by C is equal to minus C square and minus AC. Half ireko sida kana cancel to we are cancelling plus A and minus A, we have C minus B. Then for the second term, B plus C into B minus C is equal to B square minus C square, and plus for the third term sidagi A, B, A, C and B square minus C square. C grouping same anisima grouping same ko. Taking A common from first term and last term, we have B minus C. Then grouping this B square minus C square. 1 by 2 multiplied of scenario AC minus AB, B square minus C square multiplied by minus, which is equal to minus B square plus C square, and B minus C and B square C square multiplied of scenario AB minus AC plus B square minus C square. Kaduga nangi si mana-mana bakagtalasiko. Si mana-mana bakagpagkanda canceling plus AC minus AB plus AB minus B square plus C square and minus C square, and which is equal to 0. So area of the triangle formed by the 3 points ABC is equal to 0, which implies that the 3 points are collinear. Nagi points sa kay tare collinear tare ko. Then let's come to question number 4. Question number 4, Roman number 1. Find the equation of the line joining the points whose coordinates are 1, 2, and 3, 6 using determinants. Equation of the line puto kana join to boiba nangona point ani pire ko. Kay sizinaraga using determinant. Determinant ki condition se ani khatani area of the triangle putopaga condition of collinearity of 3 points ko. The condition of collinearity of 3 points apply to us. See B. Let the point B represents the first point and the C represents the second point, 3, 6 represent the oleko. And let us consider any point A whose coordinates are X and Y lie on the line segment joining B and C. B ga C ga join to line si the point EM lehele. Doi tardi si point ahom se kai tarani collinear tareko. Let A be a point on the line segment joining the 2 points B and the C. Since the 3 points are collinear, therefore area of the triangle ABC will be equal to 0. Then the area of the triangle ABC is at 0 tarani, and 1. Area of triangle ABC is given by XY 1 and 1, 2 and 1, 3, 6 and 1. Sige value na pireka, which is equal to 0. Half expand to 2 into 1 and 6 into 1. Second element is minus 1. Expanding along first row, 1 into 1, 3 into 1 is equal to minus 3, and third element is plus 1. And is cancel to right 0 sa liko. Then 2 minus 6. Hana ani se x na multiply to sinare. 2x minus 6x 1 minus 3, which is equal to minus 2. Minus plus 6 minus 6 is 0. See maong the thumb. dagi minus 1 by 2 se som nakanda cross multiplication chat ki tardi 0 into 2 is equal to 0. Then 2x minus 6 is minus 4x plus 2y 0 se lekwa. Multiply dividing both sides of the equation by minus 1, we have 4x minus 2y is equal to 0. Since 4 and the 2 are multiples of 2, so we should divide this both sides of the equation by plus 2. 2x minus y is equal to 0. 2x minus y equals to 0 have a second equation, no? Which is the equation of the line segment joining point B and the C. And is a joint form the equation. Now let's come to minors and cofactors of a determinant. Anki minors ka cofactor ka putok ko. First, let us define minors. The minor of an element Aij of a determinant is the determinant obtained by deleting its ith row and the z column in which the element Aij lies. The minor of the element Aij is denoted by capital Mij. Habdi minor of an element Aij habise kaino haitaradi, which is the determinant obtained by deleting ith row and the z column in which the element Aij lies. Aij na lies the river rows ka column ka akana phangbada kai kawi minor kawi ko. See example se anengase. Determinant A elements are 2, 3, minus 1, 0, 3, 4, and 1, 8, 2, and period ko. Question se the M11 haram tardi mase kanagi minor, no? M11 is the minor of the element A11. Element A11 means element lies in first row and first column. C2 sigi minor oiduine, which is the determinant obtained by deleting first row and first column in which this element 2 lies. 2 na lies the first row ga first column ga o. Dudi kana leme 3, 4, and I2 leme ko. Then expand this determinant. 3 into 2. Product of diagonal element is 6 minus 4 into 8 is equal to 32, and their difference is equal to minus 26. Then find minor M23. Minor M23 se putu on high doi tardi si ahan bagisna row oiduni ko ani subasini column ni. Find the determinant obtained by deleting second row and the third column. And so the determinant elements of the determinants are 2, 3, 1, 8. Si lemani second row ga third column ga 2, 3, 1, 8 leme ko. Si expand out to 8 into 2 is 16, and the 3 into 1 is equal to minus 3, which is equal to 13. So may tawragan nangi kaino se phangi ko. Degi minor putok pa hirani. Next topic is cofactors. The cofactor of an element Aij denoted by capital Aij is defined by capital Aij is equal to minus 1 whole to the power I plus a multiplied by Mij, where this capital Mij is the minor of the element Aij. Simagi minor taduine bako. So cofactor A11. A11 is equal to si ahan bagisina I की value ne ani subasina j की value ni ko. In this capital A11, here value of I is equal to 1 and value of j is equal to 1, and which is equal to minus 1 whole to the power 1 plus 1 multiplied by M11 minus 1 square direct. Then since the value of M11 is equal to minus 26, minus 1 whole square is plus 1, and it should be minus 26 mange. Then cofactor A23. Cofactor A23. Here I is equal to 2 and j is equal to 3. By the definition, A23 will be equal to minus 1 whole to the power 2 plus 3 multiplied by capital M23. Minus 1, 2 plus 3 is equal to 5, and capital M23 haidi kaino nangasai the second row ga third column ka akana determinant fangi ko. The minor of the value of the minor M23 is equal to 13. Since minus 1 whole to the power 5 sida even or the plus token odd oitardi minus sum talk to in the cofactor ki value sa minus 1 tare ko. And minor M33 hai tardi kai puto ani. Find the determinant obtained by deleting third row and the third column. Third super row sige third super column sige ko kana leme de 2, 3 and 0, 3 leme ko. 2, 3, 0, 3. By expanding we get 6, and its cofactor A33 is given by minus 1 to the power 3 plus 3, and write M33. Value of M33 is equal to 6, and since 3 plus 3 is 6, even number direct and plus 1 pangan. So may tawragan na minor putok payarani matag na kay putok payani cofactor. So the question number lere ko. If A is a matrix of order 3 by 3, then show that determinant of A is equal to A11 capital A11 plus A12 into capital A12 plus A13 into capital A13. Habadi mana mean tawse kaino nangi first row ki elements sida corresponding cofactors ina multiply tawraga moi ma'am se plus taw taraga di value of determinant taibuko. Proof: we have matrix A. Elements are A11, A12, A13, A21, A22, A23, A31, A32, and A33. Then write determinant of A. Determinant height are the elements should be enclosed within this modular sign. Expanding the determinant along fast row. Fast row the expand tawgani maramdi kaigino element A11, A12, A13 are the elements of the fast row. So we should expand the determinant along fast row. We get determinant of A is equal to A11. Find the determinant obtained by deleting first row and first column. We have this element, and by expanding this determinant, we get A22, A33 minus A23 and A32 fangeko. Second element is minus A13. See first row ga second column ga kao. A21, A23, A31 and A33. By expanding, we get A21, A33 minus A23 and A31. And third element is A13. Simapasi kaksika. A21, A32 minus A22 and A31. See question number 1 tareko. Then find these cofactors A11, A12 and A13. See values singse. Koina sidagi polasiko. Capital A11. Capital A11 the minus 1 to the power m plus 1. Then write minor m11. Minus 1 to the power 1 plus 1. 1 plus 1 की वैल्यू से क्या ताने 1 plus 1 से 2 तागदमने को 2 की देखो ना plus 1 ने चले. Then write the determinant obtained by deleting first row and first column. So first row का first column का kana ले मने A22, A23, A32 and A33 से ले मको. By expanding we get A22, A33 minus A23 and A32. Then find cofactor A12. By definition, which is equal to minus 1 to the power 1 plus 2. I, J, Nika. Then write minor M12. Minus 1 to the power 1 plus 3. Even odd fangeka, it should be minus. Then find this minor M12. First row ga second column ga go. To the A21, A23, A31 and A33 si fangeka. By expanding, we get A21, A33 minus A23 and A31. Then write cofactor A13. Minus 1 to the power 1 plus 3 multiplied by minor M13. First row ga first column, third column ga asika. First row ga third column ga elements are A21, A22, A31 and A32. By expanding, we get A21, A32 minus A22 and A31. Then substituting the values of A11, A12, A13 in equation number kya dahapani. In equation number 1 dahape ko. Then we get question number 1 dahape tuga kay fangani A determinant of A is equal to A11. Sidagi na si bawgi expression siya. Kay na represent o giverani cofactor A11. Then minus sign am yawe ko. Minus sign si sida tagrani. So element plus A12 multiplied by cofactor A12 plus third element A13. And this expression is to be replaced by cofactor A13. And hence, kaya bere, this determinant is equal to this expression. Hence, we conclude that the value of determinant is equal to sum of the product of elements of any row or column with their corresponding cofactors. Sum of product of elements of any row or column. Nang na first row the expand tau tardi corresponding cofactors se first row ani. First column the expand tau tardi corresponding cofactors se first column magadaw. Now let's come to exercise 4.4. Exercise 4.4. Write the minors and cofactors of the elements of the following determinants. Minors ka cofactors ka iyo haiba ka. Question number 2 giyan torsi. Exercise 4.4 question number 2 Roman number 2. Determinant Elements are 1, 0, 4, 3, 5, minus 1, 0, 1, 2. Here we have to find all the minors and its cofactor of the elements of this determinant. Minors kya laigani? Element mapan laitadi. There are 9 minors and 9 cofactors niko. First find M11. Element lies in first row and first column. Remaining into the determinant we have 5 minus 1, 1, 2. By expanding 5 into 2, 10 minus 1 into 1 minus 1 minus minus plus 11. Minor M12. First row and second column. Elements are 3, minus 1, 0, and 2. By expanding we get M12 is equal to 6. Then find M13, first row and third column, 3, 5, and 0, 1. 3 into 1, 3, 5 into 0 is equal to 0. Then find minor M21, second row and first column, 0, 4, 1, 2. By expanding we get minus 4 M22. First row and first column remaining elements are 1, 4, and 0, 2. By expanding we get plus 2. Minor M31. M31, third row and the first column. Third row and the first column remaining elements are 0, 4, and 5 minus 1. 0 sale 5 into 4 is equal to minus 20 ko. M32. Third row ga second column ga. Elements say 1, 4, 3 minus 1. Chileme ko. By expanding this determinant we get 1 into minus 1 minus 1. Formula gi minus 4 into 3 is equal to 12 minus 1 plus minus 12 is equal to minus 13. Last cofactor minor is M133. M133 first row and third column. 1, 0, and 3, 5. 1 into 5, 5, 0 into 3 is equal to 0 is equal to 5. Then find its corresponding cofactors. Cofactors ki definition ki matungina A11 is equal to minus 1 to the power 1 plus 1 multiplied by M11. 1 plus 1 is even number, so it should be plus 1. Value of M11 is equal to 11. Then find cofactor A12. Cofactor A12 minus 1 to the power 1 plus 2 M12. Odd oibagi minus sign ham to equal 1 plus 2. Value of M12 is equal to 6. Cofactor A13 minus 1 to the power 1 plus 3. Then write minor M13. Value of M13 is plus 3 minus 1 to the power 1 plus 3 even oibagi plus sign phange. A21 minus 1 to the power 2 plus 1. Then write M21. Value of M21 is equal to minus 4. Odd oibagi minus 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 plus. A31 minus 1 to the power 3 plus 1. Capital M31. Value of M31 is equal to minus 20. A32 minus 1 to the power 3 plus 2, 5 tare. Odd and there should be minus sign. M32. Value of MT3 is equal to minus 13 minus minus plus. Cofactor A33 minus 1 to the power 3 plus 3 minus 1 to the power 3 plus 3, 6. 6 is even number, so there should be plus sign. Value of M33 is equal to plus 5. So cofactor A33 is equal to 5. So main tawraga koina minor loy puthok pair ni ko mathang na kai puthok pair ni cofactor. Next topic is adjoint of a matrix. First, let's define adjoint of a matrix. The adjoint of a square matrix A of order n is defined as the transpose of the cofactor matrix, where capital Aij is the cofactor of element Aij. The adjoint of the matrix A is denoted by ADJA. Sin adjoint A has a represent name. Adjoint of a square matrix A is the transpose of the cofactor matrix. Cofactor matrix means matrix formed by the corresponding cofactors of all the elements of the given square matrix. Nangon the cofactor matrix to the amuka transpose law taragadi kai korani koina adjoint korani ko. Let us consider a matrix A. Elements are 2, 3, minus 1, and 0. Cofactor hanaloy puthok tare ko. Capital A11. Minus 1 to the power 1 plus 1, 0. 0 saleko A13. Minus 1 to the power 1 plus 2, minor M12. First row ga second column ga ko. First row ga second ka adi minus 1. Since determinant of minus 1 is equal to minus 1, minus minus plus tareko A21. Minus 1 to the power 2 plus 1. CD minus second row ka first column ka kay lem hore 3 lem ka. Determinant of 3 is equal to 3 and 2 plus 1 is 3. So there should be minus sign. A 2 2 minus 1 to the power 2 plus 2. 2 plus 2 second row ka first second column ka adi 2 tare. Determinant of 2 is equal to 2. Then write cofactor matrix. Cofactor matrix is capital A11, A12, A21, A22. Then a value of A11 is 0. A12 is equal to plus 1. A21 is equal to minus 3. A22 is equal to plus 2. Then write adjoint A. Adjoint A is the transpose of this cofactor matrix. Transpose ID kay hagi rows ka column ga interchange ko. Right, this first row is the first column, second row is the second column, and so the adjoint of the matrix A is obtained by interchanging the rows and the columns of the cofactor matrix. Adjoint A puthokpa hirani. Next, theorem number 1. Statement only. Statement kataniko. If A be any given square matrix of order n, then A multiplied by adjoint A or adjoint A multiplied by A is equal to determinant of A multiplied by identity matrix. Nangon the any square matrix A empirical. A duge adjoint A ga multiply to or adjoint A ga multiply to gi value sa kay gamanani determinant of A into identity matrix, where I is the identity matrix of order n. A is in a square matrix of order 1 already, I is order 1 only. Square matrix of order 2 already order 2 only. A is in a square matrix of order 3 already, I is order 3. Next, let's define singular matrix. A square matrix A is said to be singular matrix if determinant of A is equal to 0. Nangi any square matrix sama singular matrix kauni ko as exam da hangba definition ni karam kanda kauni harade determinant of A is 0 tarakan. Example matrix A 2 3 and 4 6. Find the determinant of this matrix A. 2 into 6 12. 4 into 3 is equal to 12. 12 minus 12 is equal to 0. Since the determinant of the square matrix A is equal to 0, which implies that determinant A is the singular matrix. Singular matrix ko. Next, non-singular matrix. A square matrix A is said to be non-singular if determinant of A not equal to 0. Example A. Matrix sum khale ko 3 4 and 1 2 determinant of A puto 6 minus 4 2 2 si 0 ga manabra manadre. So minus determinant gi value 0 natta basa sina kai kawe non-singular matrix kawe ko. That's theorem number 2. Theorem number 2 says statement only. If A and the B are non-singular matrices of the same order, then AB into BA are also non-singular matrices of the same order. Non-singular means magi determinant gi values 0 sattaba oitaragadi AB su BA su non-singular oiba if A and the B are non-singular matrices. So in theorem number 2 ki statement ko statement of theorem number 3. If A and the B are square matrices of the same order, then the product of the determinant of product of two matrices A and B is equal to the product of their corresponding determinants. A ga B ga si any square matrix ni. Magi determinant sigi product si determinant gi value sa determinant of A into kay ga manare. Determinant of B ga manare ko. Then remark saying si ko since koina theorem 1 da hai gibado adjoint A multiplied by A is equal to kay ga managi determinant of A into identity niko and write identity matrix of order 3. Order 3 is 1 0 0 0 1 0 and 0 0 1 niko. Then determinant identity matrix of order 3 multiplied by this determinant of A, we get determinant A 0 0 0 determinant A 0 0 0 determinant of A. Si kaise phangeko. Then taking determinant on both sides, we have determinant ki value hapselo. Adjoint A dot A determinant hape ko is equal to left hand side to right hand side, so we determinant all determinant 0 0 0 determinant of A 0 0 0 and determinant of A by theorem number 3. Sige theorem number 3 sige matungina adjoint A sisu matrix sum A su matrix sum ni ko It can be expressed as product of determinant of adjoint A and determinant of A is equal to determinant of A is equal. Determinant of A is a real number which is common to first row, second row, and the third row. Taking determinant of A common from first row, second row, and the third row, we have determinant of A whole cube. Remaining elements are 1, 0, 0, 0, 1, 0, and 0, 0, 1. Adjoint A determinant of A C amakakre. Do determinant of A whole square. Then determinant of this matrix, this determinant will be equal to 1. 1 multiplied by A square is determinant of A whole square tareko. Nasdagi ko na khangduri se kaino. A is a square matrix of order 3 neba. Aduna adjoint A the determinant lo was nangi determinant of A gi power 2 da neba. In general, if determinant of A is a square matrix of order 3, if A is a square matrix of order n, then determinant of adjoint A is given by determinant of A whole to the power n minus 1. Magi order do adagi power amahan tabo igata. Determinant of adjoint A is in a square matrix of order 2 already. It's the 2 minus 1 laani. Mga side 3 oigibagi kay case la ino 3 minus 1 la ini ko aduna sigi results yung important. Determinant of adjoint A is equal to determinant of A whole to the power n minus 1, where n is the order of the given square matrix. For today, let's end here.